Man, this sequences questions in this paper is hard, yeah, and they also went all out with the bearings and transformations. But join me for this Cambridge February-March 2023 paper 32, and I'll show you everything, and I'll show you that you can do it. Here we go, question 1, and they start off with a timetable in a cafe. So it's a coffee, and they're only open 4 days a week. Yeah, so 3 days, they got a long weekend. Oh well. They start the first 3 days of the week. Monday, Tuesday, Wednesday, they're not open. Thursday, Friday, Saturday, Sunday, they're open. So on the Thursday, they're open at 8 a.m., close at 4:30. Friday, 8:30. We don't know what time they close. Saturday, have a bit of a lie-in. They start at 9:30. Closes 5:30 in the afternoon. Sunday, we don't know what time they open. They close at 3:30, and we need to complete the table. So here on the side we say the number of hours is open. So we need to count the hours from 8 a.m. to 4:30 p.m. And for me, the best way to do this is doing the leapfrog method. Yeah, we start at 8 a.m. Okay, and we're going to jump to midday, 12 a.m. Okay, and that's clearly 4 hours. And then from 12 a.m. until 4 p.m. in the afternoon, that's another 4 hours. Be careful, yeah, from 12 to 1, 1 hour, from 1 to 2, 2 hours, from 2 to 3, 3 hours, from 3 to 4, 4 hours. Okay, don't count that 4, we're not going to 5 o'clock. Okay, and then of course we're going to 30:30, so at 4:30 p.m. that's another 30 minutes or half an hour, because that's how they write it here. So that will be 8.5 hours. Expect if you write 8.5, that's fine. If you write 8 hours 30 minutes, that should be fine as well, but try to keep it in the same format they're using. Alright, then on a Friday it's open for 7.5 hours starting at 8:30. So again, we're going to do the leapfrog method up here. Okay, so now we're counting time. Alright, so we're opening at 8:30 a.m. First thing we're going to do is jump for half an hour. Okay, 30 minutes. That will take us to 9 a.m. Yeah? And then let's go from 9 a.m. to midday again. That's 12 a.m. That's another 3 hours. Remember, we need to go 7.5. So if we got 3.5 already, we need to jump another 4 hours to get to 7.5. Okay, so from 12 a.m. we jump again 4 hours. Okay, again, calculate it from 12 to 1, from 1 till 2, from 2 till 3, from 3 till 4. That's 4 a.m. Okay, so let's keep it the same. 4:00 a.m. I think if you just write the 4, should be fine. We'll check the mark scheme in a moment. Okay, Saturday is sorted. We got the opening and closing times. It's just the Sunday. What time are we going to open? Okay, this time get a little bit harder. We can do it though. We just need to count back in time again using the leapfrog method. Yeah, so let's just start at the back now. So it closes at 3:30 p.m. Now we need to count back 5 hours. So let's just do, first let's jump back to 3 p.m. Okay, so that's half an hour. Okay, now let's jump back to midday, which is 12, middle of the day. So that will be another 3 hours. We're jumping back. So we've now gone 3.5 hours back, yeah? So we've got 3.5 hours. We still need another 1.5 hours to get to 5 hours. So let's jump that 1 hour back. Okay. That makes sense. 3.5 plus 1.5 is 5, yeah? So we jump that 1 hour back. We still need to jump. So that's at 11 a.m. Okay, so we got 1 hour plus 3 hours is 4 plus 4.5 hours. We need to go 5 hours. So we need to jump another half an hour back. That of course will be 10:30 a.m. There we go. 10:30. Yeah, it's not as easy as it looks. Yeah, 10:30 a.m. Oh, that's the last one. 4. So you don't need the zeros, but you do need the p.m. Yeah, you see, I did that. I got it wrong. What a silly mistake. I wrote a.m. instead of p.m. Oh my goodness. See, that is wrong. It should be p.m. Okay. Whew. So easy to make silly mistakes, yeah? Okay, so it says here, as you can see, the reverse calculation. Something more challenging. Okay, see, errors made was writing AM. See, I made a common mistake there, or not writing AM and PM. Okay, so do write AM and PM. That's important. And don't make silly mistakes like I do. Question B, we're still going on with the cafe. Now we're going to the waiters working there. He is paid $9.50 per hour. He's paid 52 weeks a year. Okay, so $9.50 an hour, $9.50 an hour. Times that by 29, we get how much they get paid per week. Okay, so $9.50. You don't have to put the zero, of course, but it doesn't damage to put, yeah. Okay, so now in a week, the pay they get is $275.50 per week. And they work, there are no holidays, but they only work 3 days a week, but they are no holidays. So that means you take the 275.5 times 52. Okay. We should times that 52. That is $14,326. All right, let's see if that's right. Yep. Okay, and see, you get marks for the calculations. All right, that's why you need to show it. In fact, in the general comments here, it clearly emphasizes that you should show all calculations performed. All right, show all steps in the working for multi-stage questions. So this question counts 2 marks. Okay, it counts 2 marks. You need to show some working out there. This is important. All right, you want to get full marks, you want to get good marks, listen to what the examiner tells you. Well, part 2 of question 1b, the chef is paid 32% more than the waiter per hour. Work out how much the chef is paid per hour. So what was the pay? The waiter was paid $9.50 per hour. Okay. Now 32% more. I'm going to use the multiplier method. So when you're working out 2% more, it means you take 100%, which is the money the waiter is getting paid. That's the 100%. You add the 32% that the chef is getting paid. So that means the chef is getting paid 132% of what the waiter is getting paid. Makes sense, yeah? It's more than that, yeah? As a decimal percentage out of 100, you divide it by 100, that is 1.32. So all we need to do is do 9.5 times 1.32 and we have the answer. Okay, so let's put that in. 950 times 1.32, $12.50 an hour, $12.54 an hour. Okay, there we go. Okay, and here they show all that I did, yeah. So this is my 1.32 times 9.5. Okay. Question C. Now we go to the menu. No display inside out. Cup of coffee, $2.50. Cup of tea, $2.30. Slice of pizza. I said they got 3 things in this cafe. Raj buys 2 cups of coffee, 1 cup of tea, and 3 slices of pizza. So first we need to see how much everything costs. Alright. So 2 cups of coffee will be 2 times $2.50. Okay, well that's easy, that's $5. Okay, 1 cup of tea, so that's $2.30. Okay, we can write out the whole calculation just to be thorough. And 3 slices of bread, so that's 3 times 370. Yeah, so what's that? 9, 11, 10. But you just use your calculator, don't waste time. 3 times $3.07 slice of pizza is $11.10. Okay, now we add it all together. 2 cups of coffee plus this tea. Okay, we got the 11.10 there, so we just add 230 and we add the 5. There we go, $18.40. That's what he needs to pay. Okay, but we need to calculate the change, so we give them a 20, we subtract the 18.40, and of course you get $1.60. Okay, again, yeah, just don't waste your time, just do 20 minus the previous answer, $1.60. Let's see. Yep, $1.60. The 0 is optional. There's the calculations. The more you show, the better. Okay, like I said, show, calculations, perform. You want to get good marks. Still in the cafe. Now we're going to the chef, we're going to the kitchen. The chef records the types of baguettes the cafe sells in one day. So they sold a salad baguette, cheese baguette. I guess a salad baguette is like a vegan, vegetarian baguette, yeah? Salad, egg, cheese, alright, there they are. Complete the frequency table to show this information, yeah? Okay, it's important to do the tally correct, you know, like they do in the prisons, okay? And if you don't want to make any mistakes, go one at a time. So you go salad, cheese, salad, egg. Remember, when you get to 5, you need to draw a line like this. There's no other way. This is the only correct way to do this. Done. Frequency is simply how many? 7 cheese baguettes, 4 egg baguettes, and 11. Okay. Then we need to draw a bar chart. When drawing anything in exam, please use a ruler, use a pencil. Okay. Just looks better, more likely to give you your marks. People like you better, everything is nicer. Pencil, ruler. Alright, so cheese baguettes, there was 7. Make a nice bar. Egg 4. Salad 11. Right. Alright, so your bar chart needs to represent, of course, your frequency table. So if you made a mistake here, the bars are the same, you get your marks. Make sure the gaps is the same, make sure the width of the bars is the same, use your pencil or ruler, make it look nice, then they'll give you nice marks. Question 2. Finally, we leave the cafe. Manjit asked 30 students whether they preferred joke book, puzzle books, or poetry books. Those are the only options. What about history books? What about fiction books? Anyway, so 8 students like joke books, 18 likes puzzle, 4 like poetry. So we need to calculate how big the sector is in each. And bam, as you can see, I have switched to my desktop camera so we can use our protractor and show you exactly how to do that. But first we need to find the angle, right? Remember, pie charts is all about fractions, because when back in primary school you learned about fractions, you were drawing circles. Okay, so all we need to do is write things as a fraction. So if 8 students chose a joke book, that means the fraction was 8 students out of 30. Okay, the pie chart is also just a fraction, but this fraction is not out of 30, it's about a full circle, 360. So we take that fraction and multiply it by 360. Okay, for that you just take your calculator. Okay, and that means it's an angle of 96 degrees. Okay, when we do the same for the puzzle books, 8 out of 13 chose puzzle. So we multiply that. That's an angle of 216. And the last one, of course, poetry, is 4 out of 30 times 360. 48 degrees. Okay, we need to check if that's correct. To do that, we just add them up, right? So the 48 plus the 216 plus the 96, that gives us 360 degrees. That means all our calculations is correct. If it doesn't add up to 360, then you know you've made a mistake. Now it goes on to drawing the pie chart. Okay, move this in the middle. Okay, get our protractor. Okay, the first angle I want to draw is 96 degrees. 96. Okay, to do that, I'm going to make sure the middle of the protractor is in the middle of pie chart. Then we make sure there's a 0 on the line. So we turn it until I've got the 0 on the line, like this. Okay. Now I'm going clockwise. You can, if you want, go anti-clockwise. Then the bottom 0 is on the line. Then you use the inside numbers. If you go clockwise, like I'm going to do, okay, I prefer like this one because later with bearings we do the same. Okay, we got the outside 0 on the line, so we use the outside numbers. So we go to 96. We go around there, 90. It's right there. Then the small ones, there's 95, 96. Be as accurate as you possibly can. Yeah? And use a pencil. That's very important to help you. Okay, that dot shows me where the angle is, but I only stop the line at the edge. Okay. And then immediately, so don't forget, things is clear, I write down which slice of the pie is that is joke. So right, this is the joke books represented here. Right, next angle, 216. Okay, so what we do now again, we got the middle of the protractor and the middle of the pie, and now we put the 0 on the line we have just drawn. So we need to rotate it. We kind of follow the line around. Okay, so be accurate. Again, we're going to use the outside numbers. Of course, we're going clockwise. We need to do 216, and I run out of protractor because that's 180. If you go one of the 360 ones, it's easier. You're going to go all the way, but I've only got up to 180. Okay, then I run out of protractor, so I mark where that 180 is. Okay, I need to do 216. I only got up to 180. If we subtract that, still need to go another 36 degrees, don't I? Yeah, 260 minus 180 is 36, right? That's correct, is it? Yeah, yes it is. Okay, so now I've done 180, so I'm going to keep rotating my protractor, I need to go another 36. So I put again, okay, I'm looking at this 0 here. It's on the 180 line, so it's not exactly, I might have done something wrong somewhere. I go, yeah, on that 180. 0 is now there. I need to go another 36. So there's 30, 35, 36. Okay, so that would be 216 degrees. Okay, reflex angle. So yeah, you don't have to mark that, just that's 260. More than 180, okay? And that was puzzle, so write it in, don't forget. Okay. Right, and then the last one we need to do is 48. So now here comes the big test. If this angle is 48 degrees, then we've done it right. So let's have a look. Okay, so remember I started off like this, then I rotated it around. So now again I rotate my protractor and I put the 0 on the line I've just drawn. Okay. And we use the outside numbers, 0, 40, 45. I'm like a half a degree off. I got 48.5. Okay, I guess if you go 1 degree off, there we go, now it's perfect. Okay, so look at that, it's perfect, 48, yeah, on that line. So I don't have to draw it, I just measured it to check if I was correct. I just write in there, poetry. And then you got 8, perfect. Perfect. Pie chart. Okay. So let's finish this question. Now here, one of the students is chosen at random. Find the probability that this student prefers puzzle books. Okay, easy stuff, right? Probability is always out of the total. There's 30 students. How many of them likes puzzle books? 18. Okay, do they say we have to simplify it or write it as a decimal percentage? No, they don't. So that should give you full marks, 18 out of 30. Okay, that's good enough. But if you simplify it, let's say you divide it by 3, you write what's that, 6 out of 10, or you write 3 out of 5, or you write what's that, 0.6 or 60%. They're all correct. Okay, you don't have to write them. 18 out of 30, good enough. Full marks. Right, on to question 2b, stem and leaf diagram. Of course, remember, ladies and gentlemen, that this is the stem. Doesn't want to highlight, is it? What a mess. This is the stem and these are the leaves. What a beautiful tree I just drew. Right, so first things first, they are STEM to test scores. Let's make sure we understand it. What does this mean? Test scores. There's 24 students. The lowest score gotten by students was 22. The second lowest was 25. The highest score was 67. Then the second high was 65. Okay, that's what I mean. All the scores in between. All right, mode means which score that most students get. Okay, for this we need to look at numbers next to each other. You right? If we look there, 2 students got 45. Okay, but 3 students got 51. So most students got 51. That's the mode, 51. What are we? Yeah, 51. Okay. Right, next. 75% of students pass the test. Oh my goodness, they make this harder very quickly. Work out the lowest score needed to pass the test. They don't say what is it out. Okay. 75% of students pass the test. So that means if there's 24 students, We multiply what 75% as a multiplier, 0.75, or times 75 or 100, or 0.75. So we do 24 times 0.75, 18. 18 students passed the test. That means 6 students failed. Of course, the ones with the lowest scores failed. It means this one, of course, failed. The one who got 22, and the one that got 25, and the one who got 26, and the one who got 29, and the one who got 33, and the one who got 37. Those are the 6 students that failed. First one to pass is the one who got 38. Okay, you won't be one of those 6. Don't worry, you're going to be one of these ones here that gets a really good score. Okay, so don't worry about it. Okay, but 38 is the lowest score needed to pass. That makes sense. 38. Okay, this is what it says. Okay, there's the calculations, what I just shown you. Next one, calculate the range. Remember, the range is the biggest score, the highest one. That's probably you, 67. Got the highest score, 67. Okay, minus the lowest score, 22. Was that 45? Is the range. Okay. Frankie was absent on the day of the test. It's not there. When he takes the test, his score increases the range by 3 marks. Okay. So remember we said 67 minus 22. Those were the highest and the lowest. Now if Frankie got anything in between, the range won't change, because the highest one is still there, the lowest. So if he got 34, he got 38 because he passed, okay, the range stays the same. But his score did change the range. So either Frankie didn't study, and, alright, he changed the range by 2, that means you got 19, which is 3 lower, okay, which would make the range now 48, which is an increase of 3 from 48, okay? Or, probably happened, Frankie is studied very hard, and he got 70, he got the highest score, minus 22, that's also 48, it's an increase of 3. So 2 possible scores Frankie could have gotten. He got 19, didn't study, or he got 70, he really did study. See that? Question 3. This is me, or there's a lot of food in this, or maybe I'm just hungry because it's lunchtime. A recipe for making biscuits uses 150 gram flour, 125 butter, 50 grams. So let's write that, the 150 under the flour, 125 is butter, and 50 sugar. All right, that's the ratio, 150 to 125 to 50. It's not in the simplest form, but we can by dividing everything by a common factor, and everything is a multiple of 5. So that's good. We just divide everything by 5. Okay, so 150 divided by 5, of course, is 30. Yeah, 125 divided by 5 is 25. And 50 divided by 5 is 10. Check it with your calculator, yeah? Don't try to be smart doing your head. Just check it with your calculator. Okay, but that is not. We can divide it by 5 again, because we're still already 5. Or we could have just divided everything by 25 from the start. Anyway, 30 divided by 5 is 6. 25 divided by 5 is 5. 10 divided by 5 is 2. Can we divide? Is there a common factor of 6, 5, and 2? No. So it's 6, 5, and 2. Okay. So we only divided by 5, though. If you do the third, 30, 25, 10, 1 mark, fully simplest form, 652, 2 marks. Okay, so remember now, that is to make 50 biscuits. Now that's to make 20 biscuits. What am I saying? 20 biscuits. So to make 20 biscuits, you need 150 flour. Okay, I'm writing this underneath here. Butter is 125 and sugar is 50. But now we want to make 50 biscuits. So there are different ways of calculating this. Okay, there are different ways to calculate this. We can double it, then we can make 40 biscuits. Then we can half the recipe, we make another 10. You know, you're not. So you make 20 biscuits, you make another 20 biscuits, you make 10, you end up with 50 biscuits. So you take this recipe, you take it again, you just half it. Okay, or another way to do this is simply see how do I multiply. Well, multiply 20 by 50 to get 50. So we do 50 divided by 20. What's 50 divided by 20? 2.5. We want to make the recipe 2.5 times. See, we make it once, twice, and then 1.5 times. So we just multiply all these ratios by 2.5. Okay, so we want to do 150 times 2.5, 375 of flour. Okay, we do 125 times 2.5 times, making the recipe 312.5. Make sure your 5 looks nice. And the last one, 50. So it's 50 plus 50 plus half of 50 is 125, yeah? 50 times 2.5, 125 grams of sugar. Nice. Okay. See, that's like 2.5. 50 divided by 20 is 2.5. You multiply it by 2.5. Nice. Right, we're making bread now. 600 grams. Okay, what is 600 grams? Because we know, you see, yeah, 600 grams is, what's kilo mean? Kilo means 1,000. Divided by 1,000 is 0.6 kilogram. Okay? So 1 sack of flour makes a maximum of how many loaves of bread? So how many times does 0.6 fit into 16? Did you see, yeah? So how many times does 0.6 go into 16? So we divide. 16 divided by 0.6 gives us 9.6 loaves of bread. Okay. Now we're not going to make 9.6 because we're not making 0.6 of a loaf of bread. We're just going to make 9 loaves of bread. And we're going to have some flour left. How much flour is left? Well, to make 9 loaves of bread, we do 9 times 0.6, which of course is 15, 5.4. So it's 9 times 0.6. Is 5.4 kilograms. Doesn't make sense because we got 16 kilograms. 16 divided by 0.6. That makes sense. See, that's why I always have to think carefully. This didn't make sense, did it? Okay, 9.6 was wrong. Did you see what I pressed wrong on my calculator? I didn't. I missed it. Okay. 26, because, yeah, if you use less than a kilogram of bread, of flour to make bread, you're not going to make less loaves than kilograms. So that means we're going to make 26 loaves of bread. That makes sense. Okay, so that means we need to do 26 times 0.6. Alright, so we do 26 times 0.6. Now that, ladies and gentlemen, makes sense. We're going to use 15.6 kilograms of flour. We got a 16 kilogram bag. That makes sense. Smart. So how much is left? 16 minus the 15.6. 0.4 kilograms is left. I want the answer in grams, so we're gonna have to multiply it by 1,000, which gives you 400 grams. Makes sense. You've got 400 grams left. You need 600 to make a loaf of bread. You can make a few biscuits. Okay, that's why it says in the examiner's report, it's always important to reread your question and think about your answer. Candidates should be encouraged to read questions again to ensure the answers they give are required format and the answered questions. Yeah, so. Right, the amount of flour in a sack decreases from 16 kilograms to 15 kilograms. Work out the percentage decrease of the flour in the sack. Remember, percentages, it's just kind of fractions. It's like fractions, just out of 100. So, by how much did it decrease? It decreased by 1 kilogram. Okay. So, out of a 16 kilogram sack, okay, we lost 1 kilogram. That is as a fraction. As a decimal, 1 out of 16 is 0.0625. So we lost 0.0625 of that sack. Okay? We want it as a percentage, so you simply multiply that by 100, which is 6.25% decrease. That's all it is. Percentages is fractions, is decimals. Of course, the long simple multiplication we're working out is that one. Okay. But that's how it works. 6.25%. It's all related. Question 4. 6,479 correct to the nearest hundred. Units, tenths, hundreds. We need to cut it off there. Okay, but there is a 7 next to the 4, so we need to round up the 4. That gives us 6, 5. Now this is not, you can't round 6,479 to 65, so you need to put in the zeros to keep the place value. 6 stays 6,000, 5 stays 500. Okay. A multiple of 13 that is between 100 and 110. So we just write it down, so we do trial and error. Maybe trial and error is the quickest. You've got a calculator. Let's take a guess. 5 times 13. What does that give us? 65. It's not enough. Let's do 6 times 13. Now it's going to have to be more. 7 times... No. 7 times 13. Or you can write the 13 times table. 13, 26, 39. Okay, well, I like this method. I feel it's quicker. 8 times 13. 104. Yeah, that's it. 104 is between 100 and 110. Reciprocal means you swap it, right? Now, how do you swap 0.6? They make 6.0. No, write it as a fraction, which is 6 out of 10. Okay, remember these are the tenths. So 0.6 is 6 out of 10. Reciprocal, swap around, it's 10 over 6. Okay, want to simplify it so you can. 5 over 3. Can you write 10 over 6? Well, they say 1 and 2/3 or equivalent. Or equivalent. So yeah, I think 10 over 6 will be correct. Okay, or you run a mixed number, 5 over 3. they can't mark it wrong because of that. You see, the OE means equivalent. So I'm confident my answer is correct. But also will be 1 2/3 mixed number or 10/6. They're all equivalent. Not a problem. Workout. Remember bed mass. Bed mass. Bed mass. Are there any brackets? No. Is there indices, powers, squares, roots, cube roots? Divide, no, multiply. We need to do this part first. So it's 3 plus 8 is 11. Thing is, if you just put in your calculator, you got a calculator like me, it automatically does bit mass for you, so it shouldn't be a problem. Okay, an irrational number. What is an irrational number? The most common one, of course, is pi. A number with a bunch of decimals that does not recur, goes on forever. Easy way to get an irrational number is to square any number that is not a square number. So square root of 2, square root of 3, these are all irrational numbers. Square root of 4, no, is rational, it's 2. So you do square root of 5. Go on forever, and we need to find a number that's between 15 and 20. So let's do the opposite of square. What is 20 squared? It's of course 400. Yeah? So that means the square root of 400 will be 20. So let's just try a number that is smaller than that. What about 399? So the square root of 399. Bam. You see that? That's an irrational number between 15 and 20. Now how are we going to write it down? I think writing down square root 399 is the best bet. But if you want to be thorough, put both. Show the examiners you know what you're doing. ... means it continues. Let's see what the mark scheme says. It just says any irrational number between 15 and 20. In case you can write 15.1, 2, 3, 4, 5, 6, 7. They're not very specific. Let's see what yeah. Very good. Square root 300, for example. 5 pi, so anything here. Can't just write pi, yeah, because it's not. So these are wrong answers. These are correct answers. For example, there's not the only ones. There's many correct answers. Right, question F. Write each number in the calculation correct to one significant figure. For some reason, students struggle. Just always get it wrong. You see that? This was not answered successfully because students don't round it correctly. Okay, one significant figure means you round each number to the first figure that is not a 0. So 423.8, we need to round, well, there's a 2 next to the 4, we need to round it to 400. Okay, it's an estimate. Don't use your calculator. Minus, we need to round it to that 7, but next to 7 is an 8. So it means we round it up. If it's 5 or bigger, we round it up. So the 7 becomes an 8, but the 78, you can't write 78 to 8, so it's 80. You need to put 0 to keep the place values correct. The 7, 8 is a tenth. Can't just change that. 23.5, round it to that 2, that's a 3, so it stays the same. So the 2 stays a 2, we put a 20 because it's 23. Place values need to stay the same. It's not that hard, okay? Yet, using calculator, don't use a calculator. If you estimate an answer, you should do it without a calculator. See, that's rounded to 2 significant figures. Okay, see, that's wrong. That's rounded to the nearest whole number. One significant figure looks like this. And they're going to put this again in the next exam because they always put it in and students always get it wrong. Why? I don't know. 400 minus 80 is, of course, 320. Cancel the zeros. 32 divided by 2 is 16. That's what they want. 16. No. No. Where am I? Question F. 16. Okay. It's correct. Not from wrong workings. Meaning if you don't have this, if you don't have the top part, okay, if you don't have this, you don't get that mark. If you just write 16, you get 0. Okay, you need to write the rounding to get that mark. Right, for question 5 here, we are back on the desktop. Okay, transformations. Beautiful picture they've drawn for us. Let's get to the questions. Okay, first one says measure angle C. Alright, for that we're going to need a protractor again. Okay, remember now the middle of the protractor is always in the middle there. Then we need to put a 0 on the line. I'm going to put this 0 on that line there. Okay, like this, be very accurate. So, got that 0 on the line, so we're now using the inside numbers. Okay, again, be very accurate. Okay, we got 10. You see the line is less than 20. It's below 20. I would say that's about 19. Okay, you can measure it the other way around if you want. Put the middle there. And we have the outside 0 on the line. We use the outside numbers. Again, this time it looks more like 18.5. Is it 18? Is it 19? I would say 19 degrees. That's what I'm going to write down. A quick peek at the mark scheme. It says 18. My goodness. And it just says 18. Let me show you. 18 it says. So it seems like it doesn't see anything else. Usually give that 1 degree. Let's see if there's anything in don't say anything about 1 degree off. So I'm sorry if I have to be honest here. I think I will lose my marks. So I'm gonna have to say that's wrong. 18 degrees. Okay, it shows you be very accurate. Next one. Complete these statements using 2 different words from the box. First one, angle C. So this angle here, what could it be? Is it a hypotenuse? Is this a right angle triangle? No, hypotenuse is a side, right? Hypotenuse is in a right angle triangle. It's the longest side. Is it acute? Is it acute angle? Is it sweet, like a kitten? Yes, acute angle is any angle that is less than 90 degrees. So that is angle C is a acute angle. Nice. Right, triangles A and C. A and C. Alright, let's see, right? Is it hypotenuse? No. Is it trigonometry? Well, trigonometry is everything. Pythagoras, SOHCAHTOA, sin rule, cos rule. Anything to do with triangles. So, I don't think that's it. Alright. Equilateral. Okay, equilateral, remember, means it's a triangle that has all the sides the same length. So it's not equilateral, it's not trigonometry, it's not acute, it's not hypotenuse. Congruent. What does congruent mean? Congruent means exactly the same. Is triangles A and C exactly the same? Well, yes, that length and that length is the same. This length here, that one's the same. You see, this is like a rotation. So that is, they are congruent. Okay, going on to question C. Work out the area of triangle A, give units of your answer. Okay, triangle A, I'm going to turn it like this. See, that's triangle A. Now the area of a triangle, remember, the formula for the area of a triangle is always half base times perpendicular height. Okay, now if I turn my triangle like this, I can make this the base. yeah, which is how many squares? 1, 2, 3, 4, 5, 6. 6 squares. Okay, so my formula there, it'll be half, the base is 6, times the perpendicular height, right? The height means we make a 90-degree angle. Meaning, if we take this length here, this height here needs to make a 90-degree angle. Can you see that in pencil? Yeah, you can. That's what's important with a perpendicular height. Okay, sometimes it's inside the triangle, the height. Okay, if the right angle triangle, yeah, it would be the side. Okay, anyway, the perpendicular makes a 90-degree angle with the base, even if it's over there. Ignore these 3 squares. We're looking at these 3. That is the perpendicular height. So that's 3. So that would be half times 6 times 3. 6 times 3 is 18. Half of that is 9. Okay. 9. Okay. It says give the units of your answer. Important. Always reread the question. It said that in the examiner's report. Okay. And on the grid it says this is a 1 centimeter grid, so if we use these lengths as 1 centimeter, it will mean it will be centimeter square. Be exact there. Okay. Just to get one thing clear as well, show you working out, yeah? So you need to write half, 6 times 3 is 9. Okay, it's 3 marks, and this counts 1 mark, 2, 3. Show you working out. Right, moving on to question D. Describe fully the single transformation. Remember, so it's only single. Often makes mistakes here. Triangle A onto triangle B. Right, so what do we notice here? The size has changed. Size has changed. Okay, from A to B. Now, the sign changes. It is a enlargement, even if it gets smaller. Yeah, is it from A to B or B to A? From A onto triangle B. Okay, so as you see, the height here was 6. Now the height is 2. This was 3 diagonally. Now it's 1. All right, so it's shrunk. What is it divided by? By 3. Okay, before we write scale factor, first we say it's an enlargement. Even though it's getting smaller. That's 1 mark. You see there's 3. 1 mark, enlargement. Scale factor. Alright. Now if it was from B to A, it would have gotten 3 times bigger. 2 times 3 is 6. 1 times 3 is 3, yeah? But now we're going the other way, which means you divide it by 3. Yeah? You need to do 6 divided by 3 gives you 2. How do we write that? Dividing something by 3, you make it a third. You put the 3 under the line. So scale factor, a third. 3 marks, we only have 2. The last one is the center of enlargement. Okay, and to get that, we're going to use a ruler and a pencil. And we connect the like corners. So you see this acute angle at the bottom, connected to that one is already, it's on the x-axis. This obtuse angle, let's connect those two. Alright. And that also connects the other acute angle. So those lines, they come together at this point here. And what is it? Okay, remember how to write coordinates along the corridor. So it's -4. Up the stairs, we're not going up or down. So that is 0. And that gives you your third mark. Okay, so you have to write all 3 to get full marks. Part 2. Part 2. Triangle A onto C. So A onto C, there we go. Okay, change, stays the same size. but it clearly swings around. It looks actually like a fan blade, which I have swinging here because it's very hot where I am. Right, so for that, best thing to do is use some tracing paper, right? And this doesn't have to be exact. You don't have to use your ruler. Okay, just trace this out roughly. Okay, and we put the pencil there in the middle, and you see it fits exactly. If we swing it around, it fits exactly. Nice. So first thing we say, what kind of transformation this is? Of course, it's a rotation. One mark. Okay, again, we need 3 marks. So what's the next thing? Okay, the angle and the direction. What's the angle here? Okay, half a turn. Okay, remember? You get a quarter of a turn. That's 90 degrees. You get half a turn. That's 180. So make a 180 turn is when you change direction. And then you got 3/4 of a turn. That's 270. This is all going anti-clockwise, right? So this is 180 degrees. Clockwise or anti-clockwise doesn't matter at all. So you just write 180 degrees. If you write anti-clockwise or you write clockwise, then you will just ignore it. Okay, it doesn't matter which way around you go, you get the same answer. Yeah. If you go this way around or you go that way around, you end up in the same place. So they don't care. Okay, that is 2 marks. Last mark again is the center of rotation this time. And where did we put our pencil? When we rotated it, we put it right there, which is this point here. Again, along the corridor, 2. And up and down the stairs, we're not going up or down, so it's 2, 0. And that's your 3rd mark. Right, last question. Can we see them down here? Question E. We need to show where's triangle A after a translation by vector 3, 10. Remember vectors. The top number tells you left or right. If it's positive, we go to the left. So we need to go 3 squares to the right. So if it's positive, we go to the right. Why did I say left? To the right. Just like we always go to the right, yeah? The bottom number tells you up or down. If it's negative, we go down. Okay, so we go to the right and we go down. And we're doing triangle A. So look carefully. All right? So remember, it was 3 to the right. So we got 1, 2, 3. And then 10 down, because it's minus 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nice. Okay, check where is the corners, the vertices there. Oh, you can't see it because it's gone off the screen. Okay, there's one down here. And the last corner is there. Oh my goodness, it's hard to see there. And then we connect it. In pencil. Yeah? Even if you're super confident, you know you're a genius. In pencil. Because every genius can make a mistake. Make sure the shape stays exactly the same. Right? Doesn't change at all. Right, last one. Question E, part 2, triangle A after a reflection in the line x equals 4. So first thing we're going to do, we're going to go to 4 on the x-axis, and we're going to draw the mirror line there. Nice and clear. That is the mirror line. We are doing triangle A again, so it's this one again, and now we need to reflect it. Okay. Now this means that every point, every corner of this triangle needs to be the same distance from the mirror line, but on the other side. Right? Let's start at the bottom here. The distance from this point to the mirror line is 2 squares. From left to right, right to left, we need to go 2 squares. That's where the one corner will be. Same here. From here to the mirror line, 2 squares, go 2 squares there. That's the new reflected point. And for this point here, we're on the other side, so we need to go to this side. So 1 square to the mirror line, 1 square again. That's where we're going to stop. And we connect those. Again, the shape should look the same, except now, because it's a mirror image, it's flipped over. Okay. If it looks symmetrical, it looks nice, it looks perfect, you know it's right. If it looks wonky, something is off, then it is because it's wrong. Okay. You'll know when it's right. You get this feeling in your stomach like, oh, this looks good. I know it's right. Whereas if it's wrong, I'm just checking the mark scheme here. If it's wrong, you'll know it. It would just look wrong. Alright, and that's transformations for you, yes. We're on to question 6, and we need to find the equation of the line in the form y equals mx plus c. Alright, you see this y is already there, equals, so what? mx plus c. You see there's an x, we're going to have an x there. Easy one to find in this case is c. That's what we call the y-intercept. That's where this line crosses the y-axis. You see, this is the y-axis. It crosses at 7, so that's easy. You put a 7 at the back, but we need to say, is this a positive 7 or negative 7? Of course, it's a positive 7. Because a minus 7 would be down below, right? Okay, then we just need to find what goes in front of the x. That is the gradient. Okay, then there's lots of ways of doing this. I think the quickest would be to remember the gradient m is the change in y over the change in x. Or like I like to say it, the up and down over the left and right. Okay, so there are different ways of doing this. I'll show you 2 ways. So one way is draw a triangle. This is the triangle around here already. Okay. This will be the change in x. And how long is this line from 0 to there? That's 3.5 squares. From 0 to 3 minus 3.5 squares. And then that's the left and right. And the up and down, this is the y. From 0 to there, that's 7. Okay, so this gradient would be 7 over 3.5. 7 divided by 3.5 is, of course, 2. Okay, another way I would like to do this is same thing, draw a triangle, but right, make the left and right 1 square. So there we go. How are we going to do this? Let's do it here. Let's go from minus 3 to minus 2. That's 1 square. Okay, that's 1. Then we go up to get back to the line. And look at that, that goes from 1 to 3, those are 2 values. So the gradient is 2 over 1, and that's 2. Same thing, same answer. Okay, so the answer is y equals 2x plus 7. There we go, 2x plus 7. Okay, 1 mark for each. 1 mark for 2, 1 mark for 7. Where does it cross the x-axis? Clear some clutter. Okay, so look carefully there. Yeah, there at minus 3.5 or minus 3.5. It's on the x-axis, so it's 0. Right, question C. Now we got a different graph. Okay, recognize that it's got a square in it, so we know this graph will be a parabola like this, crossing the x-axis twice, probably. Okay, so that's what the Mably immediately recognize. So complete the grid. So first thing we need to do is we need to put where the x is a -5, and very important here is the brackets. Especially when you square a number. Look how I write that. -5 in brackets squared. Okay. So on your calculator, yeah, you need to put bracket, -5, close bracket, square outside the bracket, +5, -5, +3. So we got a 3 there. Okay. Now we need to do the same. We need the same thing, but now we need to change the x for a -3. So I'm going to save some time. I'm going to go back and change just the -5 for a -3. And we get -3. Next one, -2. Okay, and now you spot it's symmetrical like a parabola. 9, 3, -1, -3, -3, -1. Guess what this should probably be? Yes, it should probably be 3. Okay, but let's double check. Let's double check. So we need to change that now for a 0. Yep, we got a 3. 9, 3, -1, -3, -3, -1, 3. This should probably be a 9. But let's check it. Let's check it. 1, 1, x is 1. 9. Brilliant. We know we got it right. Okay, there is the correct answers. Now on the grid, draw it. Alright, so we just need to plot those points on the grid above. So first point we're going to plot in pencil is -6, 9. Okay, once you plotted the points correctly, slowly, nice and symmetrical, don't use a ruler this time. By freehand, connect the lines as nicely as possible. Okay, now mine is a bit wonky. Okay, and a nice curve at the bottom. Whew. Not the prettiest. I'm struggling on this slippery screen, but I've done it. D1, draw the line y equals 6. Okay, for this you definitely need to use a ruler. Okay, y equals 6. Go on the y-axis to 6. Take your ruler in pencil. That's the line y equals 6. Oh my goodness, everything slipped. Let's try one more time. Again. I don't like it. Fourth time lucky. Okay, that's the line y equals 6. All right. Now, What are they saying? What are we doing? What are we doing? Use your graphs to solve the equation. So look here, yeah? They copied this equation. Use a different color. Okay, let's start over. They copied that equation, this one, which is the same as this one, which is the one we drew. Okay, but they've changed the y for a 6. That means y equals 6. Now where is y equals 6? Oh, we've just drawn a line y equals 6. Okay, so it means where they are equal, where the line and this thing is equal, where are they equal? They are equal in 1, 2 places. And those 2 places is where the lines cross. Now what do they want to know? They say we need to write what is x equals in those places. Where is x? X is here. So we simply need to see what is x at those 2 places where they're equal, where they cross. So you draw a line going down. Be accurate. Okay, so it's here 1 square below 1. What is that? 0.9? No, because there's only 5 squares. So it goes 0.2, 0.4, 0.6, 0.8. That's what I think anyway. I'm scared to check the mark scheme. Okay, let's do the same for the other point. Okay, remember my line is a bit wonky. So it's minus 5, minus 5.2, minus 5.4. That's my opinion anyway. Minus 5.4. Let's see what the mark scheme says. Drum roll. Well, they give you a range of answers. So mine is wrong. 0.8 is wrong. Okay, so I was not accurate enough. I was 0.1 off. It needs to be between 0.4 to 0.7. Shows you how accurate you need to be. Minus 5.4, that is correct. I'll get my mark because it's between minus 5.7 to minus 5.4. Okay, so you need to be accurate. Yeah, they are not very nice people. The people who said this more, you have to be a perfectionist. I mean, but you can do it. You can do it. Right, for question 7, we're back to the desktop, and now we're doing bearings RST, being towns in the desert, because the roads connecting them are straight lines. Okay, so this is a road, that's a road, and these are just lines showing us where north is. Note the scale, 1 centimeter is 8 kilometers. So let's go to question 7a. Work out the actual distance between R and S. So first thing we need to do is get the map scale distance. Okay. Now, I'm measuring this as 5.8 centimeters. It's 5, and then 5.5, 5.8. That is exactly what I get on mine. Now, the thing is, you see, I'm not actually using a real paper. I've printed this out. Okay, and when you print stuff out, you might change the scale. Okay, but well, we'll deal with that in a moment. Okay, the scale here is 1 centimeter is 8 kilometers. So 1 centimeter is 8 kilometers. We have now changed our scale to 5.8. So it means in this ratio, we've multiplied by 5.8. It means we need to do multiply 8 by 5.8. So use your calculator for that, which gives you 29 kilometers. Okay. Now, is that correct? Well, let's see. Wait a minute. Okay, I typed it wrong on my calculator. There we go. You see? Always double check. I typed it wrong. It's 46.4. Okay, my goodness, would never have made sense. Now the thing is, looking at the mark scheme, it is obviously different. Okay, let me show you. On the mark scheme, the answer is 48 because that distance is 6 centimeters, because when I printed out the scatter is wrong. So this is the answer you would look for, but depending on how you're doing this question, are you doing it on an original paper or a printed out one, you print it yourself, then again, you might get a different answer, all right? So unless you make a calculation mistake, like I did when I pushed the buttons on my calculator, your answer should be somewhere in this range, depending on how your paper is printed. I hope that makes sense. Back to question 7b. Another town V is on a bearing of 163 from R and on a bearing of 250 from T. Make the position V on the map. So let's just go slowly here. Okay, let's move that. We got that at the top. Okay, for this again, we're going to need a protractor. Right, now remember the rules of bearings. Bearings, we always have 0 at the top. Okay, so if we're going to measure a bearing from R, we're going to put our protractor, the middle of the protractor at R, and we're going to make sure we're on that north line they've given us, and we're going to make sure we got a 0 at the top. You see, there's a 0 at the top. Okay, it's just over the letters there. Okay, that's important. Bearings, 0 at the top always, and then always go clockwise, always this way around. That means on my protractor, I'm going to use the outside numbers. 163 is what we're going for. So we go 10, 20, 30, 40, 160 is down here. You can't see it. There we go. 160, and then 1, 2, 3. Be accurate. Okay, so I make a little mark there. Okay, this tells us the direction, not the distance. I don't know what the distance is, so I'm just going to draw a line, very light and long. Okay, so remember this angle here is 163. We don't know the distance. All right, now going for the next bit, and on a bearing of 250 from T. So this time we're going to put our protractor at T, and the same rules apply. Middle of the protractor at T, 0 at the top on that north line. Okay, and we're now going for 215. Again, we use the outside numbers. Going to go around, but only get up to 180. Okay, be very accurate. So that's 180. We are short. Okay, 180 down here. We need to go to 215. So what we need to do is 215 minus 180. What is that? 35 degrees. So we need to measure another 35 degrees. So go back here. Now I can rotate my protractor. Okay, remember, we're using the outside numbers, always. Stick to that. Okay, so swap it around. We might have a better protractor that's got 360 already on it. Okay, swap it around. Make sure now the 0 is at the 180. And we measure another 35 degrees. 10, 20, 30, 35. There we go. Okay. Again, this shows us the direction, but not the distance. So we draw a very light line here. Okay, and where those two lines cross, right there, that is where town V will be. So what's say? Mark the position of V on the map. So down here, make a nice big cross. This is town V. Okay, nice and clear. Leave all your lines, all your marks, everything. Remember now, this is 215. Okay, the more information you leave there, the more likely you're to get full marks. Okay, let's go to question C. A man cycles a constant speed of 24 kilometers per hour, straight road from S to T. So the man is cycling on this road, yeah? After 1 hour, 15 minutes, he stops at Cafe C. So he's somewhere on this line, he stops. at a cafe. You think it's a cafe from question 1? Remember? Anyway. Mark the position of C on the map. You must show all your working. Oh my goodness. Let's just see what we can figure out here. Let's first show our working out underneath this question so it's clear. Right. So we're dealing here with speed. So remember your triangle. Okay. Speed is what? This is the formula right here. Kilometers is distance. That line means divide. Hours is time. So speed is kilometers per hour, distance, time. Right. So we want to know where on the map to draw C, where along this line. What is this? This is a distance. Okay. We want to know the distance C is from the town. Okay. S. So we need to use the speed times the time. The speed we have is 24 kilometers per hour times the time, which is 1 hour 50 minutes. But be careful here. 1 hour 50 minutes is not equal to 1.5 hours. This is wrong. Okay? Because 1.5 hours is 1 hour 30 minutes, which makes sense. 1.5 hours, 1 hour 30 minutes. Okay. What we need to change is, we need to change that 50 minutes to a decimal. Now what 1 hour 50 minutes is, it is the same as 1 hour and 50 minutes out of 60. So in your calculator, you type in 50 divided by 60, and it gives you 0.083 recurring. So that means 1 hour 50 minutes is 1.83 recurring of an hour. Does that make sense? Yeah? So be careful when you change from minutes to decimal hours. Alright, this is one of the biggest mistakes people make. Okay, in fact, I'm quickly going to show you this is examiner's report. Alright, it says candidates answered well, but many mistakes, incorrect conversion of 1 hour 50 minutes. Okay, and an incorrect use of the formula, etc., etc. So be careful there. Yeah, I think that's the biggest challenge there. So where were we? We need to multiply 24 hours, the speed times the time, 1.83. Recurring. Put that into your calculator. Press all the correct buttons. 44. And what is this? Kilometers per hour, 44 kilometers. That's the working out. Now we need to indicate that on the map here. Oh, we're not finished. Okay, so remember, let's do it here. 1 centimeter is 8 kilometers. So 44 kilometers is how many centimeters? So we need to check. What do we multiply 8 by? We can do the opposite. We do 44 divided by 8. Gives us 5.5. So we multiply our scale by 5.5. So that's 1 times 5.5. 5.5 centimeters. So on here, ruler and pencil. 5.5 centimeters along the line. That's 5. Then we start at 0. 5.5 there. That is where cafe C is. You make the mouse cross. You make it C. On to question D. Oh my goodness, they don't stop here. This is a big bearing question. A hotel H is on a bearing of 321 from R. Okay, again now, yeah, there's R, so we're working from here. Work out the bearing of R from H. Okay, so I mean we can draw it on here and measure it. Okay, but there's a lot quicker way to do this. Let me make a rough sketch. Okay, where will we make the rough sketch? Okay, you've got R there. Remember now that north is always 0 degrees. So a bearing of 321 means you need to go all the way around. This is 180. You go more, this is 270. Past that. Should be over here somewhere. Okay. Draw a line. This will be a bearing of 320. Rough sketch. Nothing is accurate. Okay. So on that line, the somewhere is the hotel H. We don't have the distance. Okay. And H also has a line going north. Okay, and this north line is always parallel. Okay. What we want to know now is the bearing from H to R, going the opposite way. So we want to know is this angle here. Now there's more than one way to do this. Okay, what I like to do is simply to extend this line here. And what do we have here lying on its side? An F. An F where those two lines are parallel. Remember this? F angles is alternate angles. And alternate angles is always the same. Always. So it means this angle here is the same as this angle here. Okay. What do we know? What else do we know here? Okay. We know that this, I'm going to use my pen again. We know this here is a straight line, 180. And all of this here is 321. So I want that angle there. I simply subtract these two angles from each other. So that will be 321 minus 180 to get the answer. 141 degrees. Does that make sense? Could this be 141 degrees? Yes, because it's more than 90, less than 180. Another method you could have used, of course, is you work out this angle here, and because this is a full rotation, you do 360 minus 321. What is that? 39. So this angle here is 39. Okay, and remember, we got there a C angle. Two angles in between two parallel lines is what they call C angles. I forgot the name now. Write it in the comments, please. The name is co-interior angles. Huh? Got you. Alright, meaning if you do 180 minus 39, you also get the right answer, 141. Easy stuff. Okay, two ways to get that answer there. Let's do question E, next to this mess. The scale in the form 1 to n. So the scale is 1 centimeter is 8 kilometers. Okay. Now they want you to write it 1 to n. There is 1. That's 1 and that is 1 to 8, right? Now what they mean is you need to get the units the same. Alright. Because there's no units there. See, here's units. There's no units there. Okay, so we know it's going to be an 8. This is going to stay 1. But we need to make this into centimeters. How do we change kilometers to centimeters? Well, first you take the 8. Kilo means 1,000. So 8 times 1,000 will be 8,000 meters. 8 kilometers, 8,000 meters. Then we need to change the 8,000 meters to centimeters. What does centimeters mean? Centhion. It's 100. Century. Centurion, yeah, times it by 100. So we need to add another 2 zeros. So that's 800,000. So 1 centimeter is 800,000 centimeters in real life. So we need to write on the line 800,000. See, no units. Units the same. It also means 1 millimeter is 800,000 millimeters in real life. 1 millimeter on the map. 1 meter on the map is 800,000 meters in real life. That's all the same. See, you're a genius, you can do this. Right, on to question 8. And the rotational symmetry means how many times this will fit onto itself when you rotate it. Okay, I'm going here to Maths with Mom. Shout out to Maths with Mom, showing us first a order of rotational symmetry of 3. Because as an equilateral triangle will fit onto itself exactly 3 times when you rotate it. Okay, so you start at 1 point, rotate once, that is 1, rotate it again, it's 2, and when you're back where you started, that is 3. Here's another example. This is rotational order 2. It only swings around once. Yeah, once we go, and then twice. If it doesn't fit, other than just back in the old position, it's order 1. So the one we're looking at is like this one. Okay, order rotational 2, because if we were to make a little cross there, it would rotate, the cross would be there, yeah, and we rotate back. So that will give us an order of rotational symmetry 2. Then draw the lines of symmetry. Okay, for this use a ruler. Remember, it needs to be symmetrical. So 1 down the middle, left and right needs to be the same. Oh my goodness. Again, luckily I use a pencil so I can rub out any mistakes. Make sure it's down the middle, not wonky. And 2, again, those are the lines of symmetry. Okay, not going diagonally, that's not going to work. Okay. Two lines of symmetry drawn, yeah. Okay, no extras. No, you lose marks. Diagram 4, let's look carefully. Again, use a pencil, yeah. We're going up 1 square each time. Okay, so we need to draw a line that's 1 square higher. And also the white columns becomes more, so that needs to be, go from 3 to 4 in the middle. So we're going to do something like this. Okay, oh, again, I'm struggling to make it look nice. Let's go decrease the thickness, so we're going to shade that in. Higher and wider. Yeah. And then there's 3 white columns, becomes 4 white columns in the middle. Nice. Correct diagram. So the mark scheme is very helpful here. Yeah, I mean, it's not, but okay. All right, so let's see what is going on here. This is diagram 1, diagram 2, diagram 3, diagram 3. Diagram 1 has got how many gray columns? 2 gray. Diagram 2 has got 2 grey. Diagram 3 has got 2 grey. So diagram N always stays 2 grey columns. Okay, the number of grey columns doesn't change, so that is simply 2. Okay. Okay. Now the total number of columns, okay. So this time diagram 1 has got 3 columns. Diagram 2 has got 4 columns. Yeah, this is now the grey and the white ones, I assume. Total number of columns, yeah. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 5 columns, 1, 2, 3, 4, 5, 6, 6 columns. Okay. So we're looking at this number. This is the N. Okay, so we can write diagram N. You see, diagram 1 has got 3, diagram 2 has got 4. It's always 2 more. That's why the rule is N plus 2 for the total number of columns. Okay. Now, final expression sentence N for the fraction of columns that are grey in diagram N. So now we're looking at the fraction of columns. Okay. So here we got 3 columns and 2 of them are grey. Here we got 4 columns and 2 of them are grey. Here we got 5 columns and 2 of them are grey. Here we got 6 columns and 2 of them are grey. So what's changing? Well, the 2 stays at the top. And at the bottom, we got that same pattern before. 1 and 3, 2 and 4, 3 and 5. So that would be N plus 2. So that's it. 2 over N plus 2. Because the bottom stays the same. Okay. Nice. Now we're going to the table. First we complete the table. So check what we add each time. We add 2, we add 2. So we add 2, that's 12. We add 2, that's 14. Easy stuff. Right. Next one. We add 5. Then we add 7. So what possibly could we add next? Okay. Let me make that 5 look pretty. Okay. You need to remember all your sequences, and one that's very important is this one, the n squared. That's 1, 4. These are the square numbers. Okay, first number 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared is 9. 4 squared, 16. 5 squared, 25. This is the n squared number. Also, in this sequence, we always add 2 more. So if we add 5, we add 7. Next one, we need to add 9. It's 24. And we add 11, which is 35. So this is kind of like an n squared sequence. And then you'll recognize the next one as well. 9, 16, 25. What is after 5 squared? 6 squared, 36. 7 squared, 49. Okay. So those are the correct answers for that. Okay. So they want a rule for the number of grey squares, which goes 6, 8, 10, 12, 14. We're adding 2 more each time. Okay. Just remember, the rule is not n plus 2 because we're adding 2 each time. That is wrong. Okay. It's more like the 2 times table. 2 times table goes 2, 4, 6, 8, 10. Okay. That is what we call the 2 times table. So it will be 2n. The stuff you think you add goes in front. But unlike the 2 times table, we don't start at 2. We start at 6. That is 4 more. 4 plus 4 is 8. 6 plus 4 is 10. 8 plus 4 is 12. So we need to add 2 to the 2 times table. Okay, then the next question, they refer to the number of white squares. They tell us the rule is n plus 2. Okay. There, see the n has become a 30. So with the rule is n plus 2, we need to change the n for the 30. So we write 30 plus 2, which will give us, first bit mass, the brackets, 30 times 32, what's that, 960? Check it with your calculator. 30 times 32, 960. Okay, we're doing well. So, diagram K has a total, let's change colors here, nice, total number of squares. So we're now looking at this one here. Oh man, this is going to get difficult. Alright. You see, these are the square numbers. Yeah. But it doesn't go 1, 4, 16, 25. They start, no, I skipped one. 1, 4, 9, 16, 25. Okay, they started, instead of starting 1, they started up at 9. So it's like everything is shifted there. Right? And that brings us back to the previous part here. An expression in terms of for the total number of columns in diagram N. Yeah, that was n plus 2. But the total number of squares is n plus 2 squared. Do you understand what's going on here? This is a difficult one, yeah? Okay, so what they've done was they've added 2, which is 3, and then they square it, then they get 9. They add 2 to the number, diagram number, which is n, which is 4, they square it, then they got 16. They add 2, which is 5, they square it, they got 25, etc. So what is the rule for the number of squares? Well, this one is 2n plus 4, and this one is n plus 2. That's the white squares. This one will be n plus 2 squared. Yeah? So n plus 2 squared. So the first diagram will be 1 plus 2, which is 3 squared, which is 9. You see? 9 for the total number of squares. The next one will be 2 plus 2, which is 4, which is 16. 16. Okay. The next one is 2, no, the other one. It's 3 plus 2, because we're making that first number more each time, is 25. Okay, etc. Now they tell us the total number is 1296. Diagram K is now, 1, 2, 3, K is over here. It's the diagram. We don't know which one it is. This was diagram 1, this is diagram 2, this is diagram 3, so it's K plus 2 squared. We can solve that. We get the answer. So we're going to do, first thing we're going to do is we're going to get rid of that square, move it to the other side. What's the opposite of square? Square root. So we just do that. Square root 1296. 36. Once we remove that square, we can set free what was inside the brackets. Now we just need to move this 2 to the other side. So K is 36 minus 2. So K is 34. Yeah, this is a tough one. I agree. Okay, let's see what the mark scheme says. 8b. 8b. 3d. 8b, 3d. Oh my goodness. Candidates found this part very challenging and it proved to be a good discriminator. Oh, goodness, examiners. Alright. Meaning, if you struggle with this one, you are struggling like everybody else. But you're working hard now and you will figure this out in no time because you can do it. Question 9. Right. Stretch your back. Take a deep breath. You're almost finished. And don't let the previous question upset you. Okay, because this one is not that hard. Alright? The area of a rectangle. Remember, the area of a rectangle is length times width. The length here being 3y, the width being 2y. 3 times 2 is 6, and y times y is y squared. Easy as that. Easy as that. Correct answer only, so there's nothing else you can write except that. Next one is the perimeter. Okay, how do we work out perimeter? Well, we start at a point and we take one side, which is in this case 4x minus 50, and you add to it another side, which in this case is x plus 70, and you add to that the third side, which is 3x minus 10, and that gives you the perimeter, which they actually tell us is 526, sorry. Now we just need to solve this. Let's collect like terms. 4x, x plus 3x. 4x plus x is 5x plus 3x is 8x. Now let's do the numbers. Negative 15. That minus goes with the 50. Okay, the sign is always in front of the number it goes with. So negative 50 plus 70 minus 10. Yeah, and if you're at the end of the exam, your brain juices has run out, just type it in. Negative 50 plus 70 minus 10. The answer is 10. Positive 10, yeah? Because there's nothing in front. Now we just need to subtract 10 from both sides, or subtract the 10 from the other side. So that gives us 8x equals 516. Then we divide the 8. So we got 516 divided by 8. 64.5. Check it. Told you can do it, and you've done it. You're gonna do so well. Well done, well done.